Good morning. This is Sendil Kumar from Hindustan College of Engineering and Technology, Coimbatore. In this video, we discuss about standard penetration test from foundation engineering. Standard penetration test is most commonly used in situ test, especially for cohesionless soil, which cannot be easily sampled. In this test, it can be extremely useful to determine the relative density, angle of shearing resistance of cohesionless soil. It can also be used to determine the unconfined compressive strength of cohesive soil. And standard penetration test conducted in a borehole using a standard split spoon sampler, and the borehole is initially drilled. Next, the drill rod are removed and the sampler is lowered to the bottom of the hole. The split spoon sampler is driven into the soil mass by using hammer 63.5 kg. The mass, the total mass 63.5 kg mass falling to a height of 750 mm, and you can give 30 blows, that is at a rate of 30 blows per minute you can given to the split spoon sampler. The number of blows required to drive 150 mm penetration can be recorded, and the split spoon sampler is used to collect the disturbed soil sample. It consists of three parts. One is driving shoe, steel tube and coupling. And first one, driving shoe, it is a bottom portion of your split spoon sampler. It is made of steel and 75 mm long to cut the soil mass. And second one, steel tube, it is a 450 centimeter long. It's split into two halves in longitudinal direction. And third part is coupling. The coupling is 150 mm long. It consists of check valve and four vent ports of 10 mm diameter. The vent ports are used to improve the sample recovery. And this image shows the split spoon sampler, how the soil sample can be collected into the steel tube, and the split spoon sampler can be split into two parts in longitudinal direction. And the number of blows required to drive 150 mm of sample is counted. The split spoon sampler total height will be 450 mm, that can be split into three parts, each 150. So first 150 mm penetration, how many blows you can given, that can be disregarded, that is not taken into account. The number of blows recorded for last two 150 mm intervals are added, that is 150 plus 150, 300 mm penetration, how many blows you can given, that can be recorded. To get that value, you get standard penetration number capital N. If suppose the second 150 mm penetration you give 12 blows, and third 150 mm you can give 7 blows, means the 12 summation of these two, 12 plus 7, you get 19. So standard penetration number N value will be 19. And if the number of blows for 150 mm drive it exceeds 50 blows, at that time the test is discontinued. This is the test setup for standard penetration test. From the ground level you can give a borehole, that is by using casing pipe also you can insert it. Then next, the driving rod and cutting edge can be replaced by split spoon sampler. The split spoon sampler is marked by three parts, each 150 mm, and at the top above ground surface there is a drill rod and then pulley with the tripod stand. The pulley is used to lift the hammer 63.5 kg by manpower. And standard penetration number is corrected for two methods. One is dilatancy correction, another one is overburden pressure correction. The first correction, dilatancy correction, it is for silty fine sand and fine sand below the water table to develop pore pressure, which is not easily dissipated. The pore pressure increases the resistance of the soil and hence the penetration number capital N value. So this dilatancy correction can be given by Terzaghi and Peck for silty fine sand. There are two conditions. One is your recorded value, that is your observed value or recorded value, is greater than 15. We can go for first formula. The recorded N value NR is greater than 15, then corrected N value NC is derived from this equation. NC equal to 15 plus 1 by 2 NR minus 15. Your NR value is 19. You can substitute your NR value 19 in this formula. You get a corrected standard penetration number. If suppose your recorded N value is less than or equal to 15, if suppose you get 12, then corrected N value is given by NC equal to NR. Your corrected value also 12 and recorded value is 12. It is suitable for granular soil. In this overburden pressure, affect the penetration resistance, and the N value obtained from the field test under different overburden pressure from the different soil conditions are corrected to get a standard effective overburden pressure. And Gibbs and Holtz in the year 1957 recommend the following equation for dry or moist clean sand. So the formula is Nc equal to Nr into 350 divided by sigma naught bar plus 70, where Nc is corrected N value and Nr is observed or recorded N value from the SPT test, and sigma naught bar is effective overburden pressure in kilonewton per meter square, almost 280 kilonewton per meter square. And Nc by Nr ratio should lies between 0.45 and 2. If suppose Nc by Nr is greater than 2, it should be divided by 2 to obtain design value and then get the bearing capacity of soil. Thank you.